Hey everyone. In this video, we're going to be looking at the ionic form of amino acids depending on the particular pH of the solution that they're dissolved in. So the specific topics we'll look at are the basicity of amines, the acidity of carboxylic acids. We'll talk about isoelectric point and Zwitter ions, and then we'll look at the ionic charge of an amino acid depending on pH. And by the end of the video, you should be able to predict the ionic charges of amino acids. So think back to chapter 14 when we were looking at amine functional groups. One of the reactions that they could do is in the presence of water, they act as a base. And so this lone pair on the nitrogen can steal a hydrogen from water, and it becomes an NH3. And anytime a nitrogen has 4 bonds, it's positively charged, and the water that lost the hydrogen is now negatively charged. And so the amine is the neutral form, and the ammonium is the positively charged ion. So in the presence of water, amines can form ammoniums. Another reaction we looked at back in chapter 14 was carboxylic acids dissolving in water. And so when a carboxylic acid dissolves in water, it acts as an acid, hence the name. It gives away its hydrogen, and water will steal it. And so the OH becomes O with a negative charge, and the H2O is now H3O plus. So when you dissolve a carboxylic acid in water, it can give away its hydrogen and become a carboxylate. So carboxylic acid is the neutral form with the hydrogen. And when it's negatively charged, we call it a carboxylate. So these are old reactions. Shouldn't be anything new. But if we have an amino acid, it has both an amine and a carboxylic acid. And so when you dissolve it in water, the amine picks up a hydrogen, and the carboxylic acid loses a hydrogen. And so it exists as what's called a Zwitter ion. This is a German word, so the W is kind of a V sound, Zwitter ion. It's a molecule that is both positive and negative at the same time. So the overall charge is neutral, but it is ionic. And so it's very, very soluble in water. And so this is one of the reasons why amino acids dissolve so well in our body. They dissolve in our bloodstream, they dissolve within the fluid in our cells, highly soluble in water because they are Zwitter ions. Now, the isoelectric point is the specific pH at which the amino acid exists in this form. For most amino acids, it's like a neutral pH. It's around 7. But if you dissolve the amino acid in an acidic solution, it can form a positive ion. And if you dissolve it in a basic solution, you can form a negative ion. So the charge state on the individual functional groups depends on pH. So let's do an example. We're going to draw the structure of alanine at the following pHs. So let's start at the isoelectric point. So we know we've got the NH amine group, and we have the carboxylic acid group, and then alanine just has a CH3 side chain. So we're concerned about these two functional groups. And so the Zwitter ion is what exists at the isoelectric point. So we're going to have O minus and NH3 plus. Now what happens here at a low pH? A low pH is acidic. And so acidic solutions have H plus floating around, hydrogen. floating around in solution is H plus. That's what an acidic solution is. And so this molecule is going to want to absorb an extra hydrogen. Which functional group can absorb hydrogen? Well, the ammonium already has 4 bonds. It can't take any more. This oxygen can. And so the oxygen will pick up the extra hydrogen, and it goes back to the OH. And the nitrogen is still NH3 plus. And so this is a positive charge overall. At the isoelectric point, we are the zwitterion. It's neutral, but it's positive and negative. And then a high pH is basic, which means you have OH minus floating around. OH minus wants to steal hydrogens. Where are hydrogens that can be stolen here? Well, there's no hydrogens on the carboxylate, so the OH minus will steal a hydrogen from the ammonium. So the carboxylate stays O minus, but the NH3 is going to lose a hydrogen and become NH2. And so our overall charge here is now negative. And that's pretty much the whole concept of this video, right? Amino acids, because they have an amine and an acid group, in a neutral pH, they exist as the zwitterion, both positive and negative. In an acidic solution, it's overall positive, specifically on the nitrogen. And in a basic solution, it's overall negative, specifically on the carboxylate. And so that's it for this short video. Thanks for watching. I'll see you in the next one.